Hello guys, I welcome you to our channel Nota Bene Tech on Tube. We are doing a series of videos regarding reading books. We have done so far or covered so far one book, which is about I Still Can't Speak English by Jason West, in 2 sessions, and right now we'll able to discuss another book by Benson V. Tribe K, Business Information Management, and we're going to discuss how we can able to learn about the business management and how the processes flow, how the information flow when we talk about the businesses. And the main purpose is just to apply it simultaneously, because by the help of this book we'll able to sort out our information in a database using SQL. So the purpose of reading out this piece of information is to gain and apply at the same time, and just to build our database whenever it is needed, especially when we are dealing in more than one projects. You have to have a database that will help you to retain and help you to compile the information that you are working on as far as the projects are concerned. So for that purpose, let's see what the contents are in this book. It's about Introduction to Information Management, Data and Information, all the definition and the complementary concepts, the relational data model and SQL, and also we have data definition in SQL, advanced selection queries, joining tables, functions, aggregate and group set functions, information security management. That's we have all in this book. So I hope to complete the book in one session. If not, probably it would be covered in 2 sessions and in 2 separate videos. So we going to directly move towards the first part, which is Introduction to Information Management. The comments are like this: today business organizations create and use vast quantities of information as never before. Information has become a valuable asset to businesses. Information supports day-to-day business operations, decision making, and almost any business function in a business firm. Enterprises invest in information technology as they have proven to deliver an economic value to the business. This economic value can be expressed through an increase in competitiveness, higher productivity, increased revenue, etc. If information presents value, it can be considered an asset. Although one cannot feel, smell, or touch information, it is a critical element to almost any modern business. Absolutely right. Information can be an asset or a liability depending on the adopted information strategy or external factors. For example, pharmaceutical companies are subject to stringent government legislation. They make significant information technology investments simply to stay in business. Masses of clinical data needs to be stored and managed to comply with the regulatory requirements. On the other hand, storing too much or too little information could cause an adverse effect on a business. Sales information is an obvious asset for decision making and business's growth. However, strong information without proper analysis turns into a liability. Absolutely right. You have to be pragmatic. You have to be logical in compiling the information in spite of the regulations in a particular you can say type of business. Despite of the that requirement, compiling the information or data in a way that may help you or prove an asset on a continuous basis, it should be you can say a vision that must be followed on a regular basis. If you are not compiling the information for your benefit, to using as an asset, obviously it won't help. Just to fulfill the requirement, just to fulfill the regulation is not the objective of compiling any business information. You have to be prudent. You have to use it on a regular basis, on a whenever the business requires that the information has to be used in a way that obviously help the client help the client in fulfilling the task provided by the client. So you have to arrange the data in a way that is quick, that is accessible, and also that is useful. And data and information. The notion of information is the basis for building an effective understanding of the place that information systems occupy within a business and more widely within the knowledge economy. It is especially important to understand distinguish between data, information, and knowledge, and realize how they help organizations achieve their business objectives. Let us get back to basics and consider a few fundamental terms. Businesses collect and store all sorts of data, whether they are necessary facts about their daily operations, customers, or products. Raw, unprocessed streams of facts are usually referred to as data. The same question has also been asked in our summary questions, I believe. Just going to see, and you can answer accordingly. So raw, unprocessed streams of facts are usually referred to as data. Okay. Because it is not in a specified form, it is not in a refined form, then mean it is actually a data. Entries of numbers, text, images, or other forms of computerized output are considered data. Raw data, however, is a relative term, as data processing may have a number of stages, so the output from one processing stage can be considered to be raw data for the next. Yes, obviously in a businesses there are a number of stages of completion, there are a number of stages of information, and one information may be or may not be relevant to another stage of a business. So for that reason, the output from one processing stage can be considered to be a raw data for the next. Yes, if it is considered refined data in a one stage of a business, it may be a raw data for the next stage or for the next process. After data is processed and shaped in a meaningful way, useful to a person on computer, it turns into information. Absolutely right. And the purpose of doing and reading out this book is that we are moving towards understanding how we can have all sort of relevant information or data, obviously available on the internet, and we can use and we can help ourselves to compile that data or the raw data into relevant information that may help us to grow our business in a very relevant, you can say, a form, or also in a relevant path. So let's see what we have ahead in this. Data information. The difference between data and information is determined mainly by how they are used in a business context. An individual entry on a sales receipt which has a product name, quantity, and price does not become informative to the business unless it has a purpose or a meaning. Yes, information must have a purpose, information must have a meaning for the business. Okay, so sales receipt, having an individual entry on a sales receipt showing the product name, quantity, and price does not become informative to the business unless it has a purpose or a meaning. For example, the fact that 3 cans of curry sauce have been sold at a grocery store may not be very useful to many. However, the difference between data and information becomes clearer when data is transformed into information for a business purpose. Yes, whenever the data is transformed into information for a business purpose, then it becomes more clearer between what is the data and what is the information. For example, sales entry of the same curry sauce are analyzed per quarter, and this information becomes useful to compare quarterly sales to the target figures. When individual data entries are processed, some utility, value, or meaning is added to raw data to transform it into business information. This is how we normally differentiate between the two. Organizing data in order to be useful to business and effectively support business processes. Data used throughout a business is organized using a data model. Yes, as I said earlier, we have to apply on a regular basis. We have not to just compile it, we have to compile it in a way that is relevant on a regular basis. So we have, for that reason, we have to follow a data model. A data model provides a set of principles for organizing data. Generally, data items are arranged into hierarchy comprising of data elements and data structures. Yes. A data item is considered to be atomic, or the simplest element of data organization that cannot be divided any further. For instance, in a data model for organizing customer records, it is not recommended to keep names of individuals as a single data item. It is typical to have separate data items for first and last names of an individual, that is, to keep each element as simple as possible. At a first glance of data, see figure 2, it may not be obvious that a name records such as Jackson Taylor and Taylor Jackson are not the same. So in the name given below, Jackson and Taylor, the last name is Jackson, the first name is Taylor, and the Taylor Jackson, the Taylor and Jackson non-atomic data item is in the first column, starting from left to right, and 2 atomic data items in a data model. So you have separated it by the last name and first name, keeping it as simple as possible, and obviously it is so you have changed the sequences. 2 atomic data models in a data model. So data items in a data model. So these are the atomic items, data items. And as I said, a data item is considered to be atomic or the simplest. These are the simplest element of data organization that cannot be further divided. For example, in the data model for organizing customer records, it is not recommended to keep names of individual as a single data item. Typical to have separate data items for first and last names of an individual, that is, to keep each element as simple as possible. So you have to organize the data into a hierarchy of data elements and data structures. Okay, so choice of data model elements is in front of you. So meaning is that there are 3 terms: data items, data elements, and data items are arranged then into data elements and data structures. And we have a data model, and also a data item is atomic or non-atomic. Okay, so these are the terms we have just came across by this read. The hierarchy nature of if a data model is based on the fact that data element is grouped of data items, and consequently a data structure is a logical collection of data elements. Data structure, data element, and data item. The hierarchical nature, or if a data model is based on the fact that data element is grouped of data items, and consequently a data structure is a logical collection of data elements. Yes, this is how you're going to arrange data structure, data element, and data item, or starting from the bottom: data item, data element, and data structure. For decades, the most popular data model used for data storage within organization has been file-based. Obviously, most of the databases are file-based. In this data model, logically organize constructs of fields, data item, records, data elements, and files. Data structures are used to organize data. So in context of a file-based model, a record can be considered a data element. Okay, the structure or so-called syntax of a typical record comprises of a set of data items that generally represent a meaningful entity. For example, businesses typically store their customer data. A customer record may consist of a data items such as customer name, address, contact, telephone number, etc. A collection of customer records form a data structure stored in a file. A collection of customer records form a data structure and stored in a file. Okay, so the record itself is a data element, and all okay, and okay. Yes, a customer record is a data element, and the details of the customer is the data element, and the details of the customers within a data element is each information is data item. So all is stored in a file which we name as a data structure. So organizing records together in a specific file means that there exists some sort of a relation between data elements. Yes, organizing records together in a specific file means in a data structure means that there is some sort of relationship between data elements. And for example, a particular business organization stores data from about its customer orders in a file-based form. Various order records may be stored in different files to create categories or that are meaningful. For instance, individual files may contain order records placed in different years or handled by different sales consultants. Therefore, a particular data model itself adds some sort of meaning to the data. For instance, individual files may contain order records placed in different years or handled by different sales consultants. Therefore, a particular data model itself adds some sort of meaning to the data. Yes, you have to arrange it. You have to arrange it in file-based form, and for example, individual files may contain orders or order records placed in different years or handled by different sales consultants. Therefore, a particular data model itself adds some sort of meaning. Yep, obviously. When you have the record of customers, and in the customer records you have the information, and you are storing that information in organized form in a data structure that is called files. Different files can be knit together, and you can create the categories of a specific record when within different files, and also just to have giving them some meaning or reference to be used for future purposes. In a data model individual individual data item is characterized by some sort of a format, typically referred to as a data type. Yes, data type indicates not only acceptable form of a data item, but also its format and possible range. Furthermore, data type declares the appropriate operations that are possible on a data item. For instance, a typical data item in a customer record data structure is a telephone number. Okay. The data item, data type choice for this item may be difficult. Okay, if we declare it to be an integer, in many cases the first zero in the telephone number may be lost. However, if we declare it to be a string of characters, then it will be possible to store not only the digits but additional characters such as the inverted commas indicating where the country code is placed in the number. A string data type will allow storing of additional non-numeric characters. However, this may make sorting telephone numbers by area code challenging, as values given and this are equivalent. Okay, so that meaning to say you have to specify a data type as well. Just reading out at this till this information, obviously when you're going to store the data item and with a type which has to be, you can say, a string form, the string form will not going to allow you to will differentiate between the two formats, because the format will allow you, the string format will allow you to have the non-zero integers as a starting non-zero numbers or non-zero numbers with the non-zero integers starting from initially. But considering these two examples, obviously zero, if you're going to consider it as an integer, the data type is an integer, the zero would be lost. So we have to consider the string so that the data can be recognized. But the problem is that it become more challenging. So let's see what it says ahead. Now, over the years, a series of standard data types have emerged. Okay, so overcome this problem, because by using the string we have sorted out the problem of using or of avoiding losing zero at the start. But obviously what the problem is that it may actually add to some complex situations. So for that reason, the standard data types have been emerged. Data types commonly used by business information systems include numbers, text, date and time, and others. Standard data types such as text are a series of characters composed of characters from the alphabet and other symbols, and numbers, integer, decimal, float, and other types of numbers. And time, including dates, seconds, minutes, and hours, are among most commonly used in business information systems. Including dates, seconds, minutes, and hours are among most commonly used in business information systems. Computers and other electronic devices store data using strings of characters coded based on a standard character set. Although invisible to a average computer user, encoding a character set represents a standardized coding scheme. For instance, a text consists of symbols or letters. Each letter or pronunciation has a corresponding sequence of symbols from the encoding set, uniquely representing this text element for hardware and software manipulation. And ASCII, American Standard Code for Information Interchange, has become a default standard character sets used on most personal computers and workstations. The ASCII coding system scheme based on the English alphabet provides encoding for 128 symbols. In ASCII, the capital A is represented by the binary string or number this. Although it is difficult to imagine that a few decades ago computers supported only English alphabet, most modern internationalized encoding standards evolved based on ASCII. So these are the point is that the standard data types have been emerged, which are a text and a date, time, and others. Talking about the text, it is composed of a series of characters, and they may have the alphabet as well, the numbers, symbols, the decimal, float, and other types of numbers as well. And we're talking about the data standard of data type of time that includes dates, seconds, minutes, or hours is used in the business information system. So what computers and other electronic devices are stored, how these computers and other storage devices are storing the information is based on the coded system, and it is a standardized coding system internationally used. So ASCII has been in use for quite a while, because even if it has introduced a binary system for a string so that the numbers can be stored in 1 zeros and 0 1s. So the problem of not you can say differentiating the string or the integer, that has been resolved by using the ASCII coding system. So in recent years, it becomes impossible to store data only in standard data types. Modern information systems have to copy with multimedia such as graphics, audio, and video data. This leads to the development of new data types to allow encoding of a wide range of data in digital form. Yes. So modern information systems, because of that, we use graphics, audio, and video data on a regular basis. Because most of the information is now being graphical, is now being in a video and audio base. So more encoding has been involved. So for that reason, we have to store it in a wider range in digital form by encoding it. For example, data elements of a photographic image are pixels. In fact, the term pixel originated from a picture element. Okay, we have talked about the element when we are talking about the data item, data element, and data structure. So when we're talking about the record, so in this case, pixel originated from picture element. Okay, typically a good 4 by 6 inch print requires an image resolution of at least 800 by 1200 pixels, what is essentially a grid of individual pixels, each with its own color code and other properties. To devise a data structure for storing images, we need to consider pixels as individual data elements with data items containing color corresponding to each pixel. Although quite a straightforward to visualize, it is not the most efficient data structure to store, and many image compressing techniques have been developed to minimize the hard disk space occupied by multimedia data. Yes. Using the pixel as a data element has now been replaced because of the modern compressing teams as per this read. So just to minimize the hard disk space. So it is very important that how we organize the image by recognizing pixel as a data element and obviously storing it according to the individual pixel of an image with its respective color coding and other properties. Whether we are considering text, numbers, or multimedia, data has to be represented in some way for storage using computer hardware. Okay, whether we are considering text, numbers, or multimedia, data has to be represented in some way for storage using computer hardware. Obviously, that's right. We have to store in some hardware. Data in its various types are stored by hardware using binary representation. As I discussed earlier, a unit of the quantity of data stored is typically expressed using bits. A unit of the quantity of data stored is typically expressed using bits. A unit of the quantity of data stored is typically expressed using bits. 8 bits make up a byte, okay, which we are more accustomed to by now. Over the years, capacities of hardware used in modern computing have grown exponentially and will continue to do so. Yeah, absolutely right. 8 bits equal to a byte. Typically, hardware storage capabilities are specs in kilobytes, megabytes, and gigabytes. So kilobytes, 1000 bytes 10 raised to power 3, megabytes 1 million bytes 10 raised to power 6, and gigabytes 1 billion bytes 10 raised to power 9 is the representation of the different volume of data. Information everywhere. Where is information which makes a business run? Well, the answer is probably everywhere. Information can be in a variety of forms and is stored in various channels. Almost any business is now operating a database, a structured approach to information storage. The corporate database often becomes the center of business operations and decision making. Some or all of the business areas can draw on the information stored in the central database. As okay, obviously organizing the data in a structured form should be the main reason of any business, because normally the business should be run, the operations are run on the basis of the information stored in a database. So it has to be structured, centralized database. Access is like this: sales and marketing, finance and accounting, production, human resources are the 4 departments knit together. And okay, so what we have this scoop. Okay, at the operation level, decisions are made to ensure smooth running of operational processes or day-to-day business. At this level, it is necessary to oversee that resources are used efficiently, inventory is up to date, production levels are as planned. Decision making at this level requires information almost entirely internal to the company, although it may extremely detailed and real time. Okay, so yeah. Information for decision making at management level has a typical time frame ranging from weeks to several months or a year. Middle management usually controls medium-term scheduling, forecasting, and budgeting operations. These rely on internal as well as occasional external information. For instance, setting the quarterly budget requires the knowledge of current expenditure as well as external pricing information. Senior management will focus on general or strategic issues related to overall business development in the long term. At this level, decisions tend to relate to issues with long term, such as restructuring, major financial investment, and other strategic undertakings relating to company's future rather than present. Information necessary for decision making at this level is comprehensively gathered not only from the internal sources of the company itself, but also involves external information such as data related to economic situation or sectors as a whole. Businesses that heavily rely on information develop on information strategy to establish how to manage information for business advantage and to comply with government regulations. An information strategy is a planning document usually created at the strategic level by the Chief Information Officer, possibly together with the Chief Technology Officer and IT Manager. So it is a new document. An information strategy is a new document. We may discuss in our writing documents plan as well on a video. An information strategy is developed to support the overall business strategy of an organization and explains how information should be captured, processed, used, and disposed of throughout its life cycle. Although the structure of an information strategy varies from business to business, there are some common areas included in most information strategy documents, such as shown below. Construct overview of information resources, summary of resources, their utilization by internal staff and external stakeholders, key projects, budgeting. Okay, that is the overall information. And information architecture and IT structure, description of the IT infrastructure, key projects, itemization of data sourcing and other purpose. External factors, analysis of the competition, the economy, government policy, and technological advances. Opportunities, analysis of new business opportunity arising from information and technologies, a risk analysis, a description of internal and external threats, analysis of compliance with regulations, summary of information usage by competitors. Schedule, list of milestones and review dates to indicate if the strategy is executed well. So these are the table that you may use for the information strategy as a document. And it is on the senior or management level. So what's the rest? To provide specific guidelines to their employees, contractors, trading partners, and other external stakeholders on the processing, storage, and communication of various types of information, business firms usually create an information policy document. This document is extremely important when an organization handles security-sensitive data or is subject to government guidelines related to information processing. It defines sensitivity levels of information and lists who has access to each level. The aim of the information policy is to make sure that information assets of a company are appropriately protected from threats or disclosure. Obviously, normally there are security sensitive data for the running of a business itself. So the information policy needs to be documented well at an operational level and at the management level and also at the strategic level. Okay, data processing software is an enterprise. Business organization use a wide variety of software tools to help the business run, from spreadsheets to complex enterprise resource planning systems. Information processing tools help business firms derive value from their information assets. The table below attempts to list various types of software and their business purpose. Although the scope of this text does not allow consideration of all software applications in a modern business, the list below gives us a glimpse of how sophisticated data processing mechanism could be. So that is spreadsheets, desktop spreadsheets, web-based spreadsheet, offer powerful data entry and analysis tools, automatic recalculations, and other analytical capabilities. And the types of data manages operational and adds online collaboration capabilities, allowing a simultaneous communication and collaborative editing by multiple users. That is also operational. And database systems and database management systems permits to efficiently manage, secure, and analyze data as well as interface to other software applications. That is at the operational management. Data warehouses aggregates data from multiple operational databases, processes, and supports enterprise-wide operations, operational and also management and also strategic. Online analytical processing supports business intelligence through multi-dimensional data analysis, that is management and strategic. Communication and collaboration, intranet, blogs, wikis, social networking, support information dissemination across business. Email, video conferencing, communication and collaboration is the purpose. and it is at the operation level. A specialized system, enterprise resource planning, provide an integrated approach to enterprise data management by integrating financial information, sales, manufacturing, human resources, offer complete information solution to enterprise overall performance, that is operational management and strategic. Customer relationship management, consolidate customer data from different sources and help streamline dealings with customers, that is operational management and strategic. Knowledge management systems provide functionality of knowledge discovery and knowledge repository, and operational management and strategic. And information represented in people, knowledge, experience, and innovation has become a driver of competition. Making the information work for a business is one of the managerial responsibilities. As you can see, managing information is not an easy task. Absolutely right. So in summary, information is the backbone of operations and survival for many modern business. Information is distinguished from data as a result of data processing operations. After data is processed and shaped in a meaningful form, useful in business environment, it turns into information. In order to be useful to business and effectively support business processes, data is typically organized using a particular data model. A data model determines how data items are arranged into a hierarchy comprising of data elements and data structures. Data items are characterized by a data type. Standard data types include numbers, text, date, and time units, with more complex data types are now available. In order to distinguish various types of information processed and generated in a business organization, it is necessary to distinguish between strategic, management, and operational levels in an organization. Information required by each level differs in its origin, external or internal to organization, time frame, long, medium, or short-term, level of detail. How a business aligns its information assets with its business objectives is stated in the information strategy document, whereas practices on information capture, use, risk, and security are typically specified in an information policy. Ever-increasing complexity of modern businesses has led to the emergence of a wide range of software designed to help business derive value from their information assets. Such software ranges from spreadsheets to integrated enterprise resource planning systems, with more and more emphasis being put into collaboration and communications features of modern software. So these are the review questions. You can answer it accordingly. We have discussed all these, and I can also offer most of the questions right away. So case study: Walmart harnesses RFID technology to improve efficiency. Walmart Stores Incorporated is a global retail giant serving 176 million customers weekly. The company operates in 14 markets from United States to Japan. Walmart uses thousands of suppliers in every merchandise category. They range from one-person shops to multinational corporations. Some sell products in just a handful of stores, others supply nationwide. The efficiency of Walmart's supply chain, yet to be duplicated, is a major factor in the company's retailing success. Walmart leverages cutting-edge technology to streamline in business operations. In order to further improve its supply chain management, Walmart has chosen to adopt RFID technology, tags with embedded electronic product codes, EPC. Essentially, these smart tags are expected to replace traditional barcodes on all Walmart inventory from crate or pallet to the unit level. RFIDs provide accurate data about inventory levels and other detailed information and deliver the benefit of precise inventory management. So radio frequency identification, okay, is the acronym relies on storing and remotely retrieving data from microchips or RFID tags for automated identification. The real-time information on products and inventory, reduction of human errors from manual operations, and improvement of information integrity are some of the improvements RFID can deliver over the existing systems. RFID tags have been available for a number of years, but they have not been adopted widely due to cost issues as compared to barcoding and because of interoperability problems between tags and data readers. Okay, IT managers and technology vendors alike agree that RFID devices still need to overcome major manufacturing, pricing, and standardization problems before widespread usage can begin. Walmart's technology shift is expected to result in the deployment of nearly 1 billion RFID tags for tracking and identifying items from carat to pallet levels. Crate to pallet levels, and RFID tags can gather and track a variety of data related to products and materials. Okay, supporters of the technology say that RFID tags can store more detailed information than conventional barcodes, enabling retailers and manufacturers to track individual items. It is more sort of the read as an altogether is more sort of a manufacturer based type. Obviously, it is you can relate to the services, or if you can just extract the chunk of some of the the read and extract, and you can apply it to the services industry. But more generally speaking, it is more sort of manufacturing type read. So, although an adoption of the new technology has been a part of Walmart's strategic objectives for a number of years, the cost of the new technology has now been discussed widely for either the company itself or its suppliers. The cost of technology has decreased significantly from 50 cents per tag in 2003 to 5 cents per tag. For Walmart suppliers, however, the cost of the tags alone could total $50 million. Besides millions of RFID tags, large suppliers could require thousands of readers at a price of at least $100 per device for all their manufacturing facilities and warehouses. To the proponents of privacy, the idea of having a unique identification tag on every product they buy is alarming. Ubiquity of RFID readers could mean that every time you pass by an RFID reader, it could uniquely identify your sweater or shoes. Hypothetically, it may be possible to link credit card records with an RFID tag on your clothes and thus monitor your every move. Despite the criticism from consumers, and suppliers, Walmart continues its RFID technology expansion. According to Walmart Executive Vice President and CIO Roland Ford speaking at the RFID Journal Live, the current benefits of RFID tagging system include a 30% reduction of out of stocks, reduction of excess inventory in the supply chain, and sustainability impacts. So these are the recommended as well. So you can have the discussion questions. You can apply accordingly. If you are interested, we can read it out and apply it as well. So relational data model and SQL. Okay, so why not to keep this for our next session? I hope so that we can move ahead and complete the book. Okay, so see you in the next session with the same section. Thank you very much. Take care and have a nice day. Okay, in this second part, it has been discussed as relational data model and SQL. So scenario is Dream Destinations. Dream Destination Limited is a company that provides a top quality service in bespoke, tailor-made holiday packages. They arrange everything from flights, hotel accommodation, and trips to destination within the Caribbean. At present, they only record data from phone calls and emails on paper notepads, and these are put inside filing cabinets. They have no methods for storing customer, hotel, or flight information and have difficulty in keeping track of information. They only advertise by word of mouth, cold calling, telesales, and advertising through print media such as their own travel brochure, which can be found in travel agents. Dream Destination Limited have realized that should something happen to the paper files, for example an office fire, their data would be lost as they have no way of keeping data. They want to be able to access the required information quickly and efficiently. They also need a means of advertising themselves to increase their customer base. They have asked for us to create a means of storing their data, their client booking, and property information. The relational database management systems have become the prevalent means of managing data, and RDBMS comprises of software facilitating storage, entry, and data retrieval. Modern RDBMS rely on the relational data model to organize records within. Relational database are organized in entities, attributes, and tuples. A tuple or a record is a set of attributes, and an attribute contains a single piece of information, and an entity is a collection of tuples. A phone book, for example, can be thought of as a database file. It contains a list of records or tuples. Each tuple consists of 3 attributes: name, address, and telephone number. A relational model, which is the heart of all RDBMS, relational database management system. In simple terms, data is manipulated in tables, sometimes called relations, and at a conceptual level, several layers above how the data is actually stored. At a conceptual level, several layers above how the data is actually stored. So it is the main theme of the relational data is what you can say, organizing in entities, attributes, and tuples. So we have discussed tuple is a set of attributes, and each tuple, for example, in case of a phone book, it has 3 attributes, which is name, address, and telephone number. So the table relation concept, client table is in front of you, having the client number, file name, and file name, first name, the last name, telephone number, and preferred type, and maximum rent. So this is the client table. Each table must have a unique name, client in this case. Each row record is a series of interconnected data items. A client in this case, the client table shows 4 rows and 4 clients. Okay, this is being shown. A cell must hold one atomic value. For example, a value that won't normally be divided into any smaller parts. Values can be text, for example, letters or alphanumeric characters, numbers, so that associated mathematical operations can be performed, or other types such as data, dates, times, or currency. The client table contains a set of clients that use the Dream Destination Limited services. Each column must have a unique column name to that table, which indicates the kind of data items shown in the column below. Every table is supposed to mirror a mathematical set, and as such, there is no significance in the row or column ordering. Theoretically, there are also no duplicate rows allowed. Actual database may allow duplicates. A table is sometimes called a relation in mathematics. Okay, so this is how you'll use we are using the relational data model, and creating the tables and storing and creating our own database for all the processes, and when tabulating it in a tabulating form, in a tabulation form, all the data is stored. Operations on a table are based on the mathematical principles of selection, projection, join, and product. These terms come from an area of mathematics called relational algebra. Okay, in reality, these operations are performed through a language such as SQL. Yes, so what we want to do, we want to tabulate the data, and obviously in a table form, and using the mathematical principles which we normally use in relational algebra, such as selection, projection, join, and product. And how we're going to use these operations with the help of SQL, which is a language. So starting access. In Windows, the Access database package can be started by finding the Access menu type, which is typically under the Microsoft Office menu, or by clicking on the Access icon of one is visible on the screen. Activity 1. The first exercises in this chapter use the database SQL lab sessions.accdb. This is available through the online supplementary resources. After saving this file in your hard drive, use the file open menu item to start a new database session. We can show you separately by accessing and using the access and showing obviously the file and the opening of to start a database session. The file format, Microsoft Access saves each database in a single file with the extension .accdb. That is the extension. Note that this is the unusual. Most other database save information in several files with differing file extensions. Note that Access file formats have changed significantly between versions. Access 97 files can be loaded and updated in Access 2000 or Access XP. However, once the changes are saved, it may no longer be possible to open the file in the previous version. Okay. The main interface, unlike Microsoft Word or Excel, Access offers available features and facilities for each database through a dialog box on the left-hand side of the page, which is open when the database is in use. Okay, this is in front of you. So booking table, client table, and owner table, the property table. So you can have these within the table section. Despite the many versions of Access that have been made available in recent years, Access 97, 2000, XP, the core functionality has remained the same. Microsoft has frequently changed the GUI, so items may be placed differently on screen. For example, some version of Access 2007 places the items to create new tables, queries, forms, reports under the current tab, under the Create tab. Okay, you can go and create it by yourself. Okay, and clicking on the table button allows new tables to be created. Okay, existing tables to have the design change. Double click on an existing tables to be used to open. Here, 4 existing tables can be seen: property, owner, client, and booking. All have the word table after them. Clicking on the query design under the Create tab button allows creation of new queries. Double click on an existing query, in this case called Select All, to be used to open. Okay, so you have all the steps in front of you how you can create a table, or you can view the already created tables. Your database does not have any queries designed yet. Okay, you want to design a query, then let's see what is all queries about. It will be discussed in the next section. Dream destination tables used. These are the, obviously it is as far as the booking scenario is concerned, for this flight and all the destination and all the scenario. This is the query, the table, or the is a case study. The SQL Lab Sessions database contains 4 tables: property, owner, client, and booking. Property is a table containing property to be rented out, information such as property number, street, country, rental cost, and the yearly income. Owner is the table containing the details of the owners of the properties. Client contains the detail of people who want to rent the properties. Booking contains the details of clients who have booked a stay at a property. So with the help of these tables, you can arrange the data according to the title, according to the columns, so that you can have all the information stored in a relevant way, and obviously you can use it later on. So this is how you're going to use it, and tabulate. This is all about tabulating the information and storing the information or the raw data, and using the raw data converted into the information, later on converted into tables by using SQL, using Access. And here it is, the study in case study. The data manipulation SQL is a standard database language supported to have some extent by every database product on the market today. Until the mid-1980s, almost all mainframe databases were either hierarchical or network databases, which lacked a rigorous mathematical foundation and were often implemented in a messy or inefficient style. In 1970, E.F. Codd published a paper which provided a relation model for database based on set theory. It took 10 years for IBM to produce a System R based on this relation model, which included a query language called SQL. Okay, during the period 1980 to 1983, IBM announced versions of various operating systems and machines, such as the power of IBM at the time that many other companies announced a version of SQL for other machines, for their machines, either as a replacement or as an alternative for their proprietary language. Okay, this is a bit of the history of a relational model based concept. And to prevent there from being multitudes of versions with different dialects, ANSI and the ISO Standards Committee have produced documents detailing various standards and extensions, SQL1, SQL2, SQL92 and SQL3. SQL1 was produced in its initial form in 1987. The second version was published in 1992 and is still having subsidiary sections added. The current standard is SQL3, which can still be regarded as a draft. There are few databases that actually support this standard. Most of them offer SQL92 compatibility. Okay, so right now we are in a phase of using SQL3 in most of the cases. Dream destinations, database tables, property table. Okay, this is again the same case study with the database tables, and here it is the property table with the details in front of you, the relevant details as shown. The owner table with the relevant details is also in front of you. The client table, the booking table showing the client number, the property number, booking date, and a comment. And starting and editing SQL. What is a query? Query can be classified as a question that we require the database to provide an answer to. Okay. Example queries could be questions such as which property has an income of more than 11,000 euro or pound per year? What will be the rental figures look like if we increase them by 5%? Okay. After creating the query, we execute run it, or in access terminology, we open it, and the database produces a response that, for example, brings us the information we asked for. Queries can be edited and then re-executed if they are not quite correct. Okay, right. The access query mechanism: clicking on the create tab and the query design button. Only click this once the query design view. Only click on the close button. Okay, we can show it as this in front of you. You will notice that your top toolbar will be on the query tools design tab. Click on the SQL view button once. So this is how it has been created. You can create the query. Query is just the question, and we want a response in terms of a language, in terms of a table, and by creating a table and using the process in front of you. Okay, so a blank database, and the database supplied with text will have no query saved, so the dialog box will contain two entries offering ways to create a new query. Activity 3: follow the above steps to get to the SQL view of a query. The three main views. As you have not created an SQL query, you will only have access to two views, SQL and design. See below. Once you have created a query, you will have access to more views. Okay, views before creating a query, views after creating a query. Okay, so after creating a query, after creating a question, you can have more options to view, so that you can use it as a data sheet view, as a pivot table view, pivot chart view, and before that is just the SQL view. So it's all about practicing and implementing what we are doing or seeing right now. The design view allows every query creation using a drag and drop principle. Although easier to use and learn, this interface is not transferable to other databases and will not allow all queries to be written. The design view allows every creation using a drag and a drop principle. Although easier to use and learn, this interface is not transferable to other databases and will not allow all queries to be written. Okay, this is the design view. Now the SQL view allows the SQL source to be viewed in a primitive text editor. This is the principal way of entering and editing SQL text used on this course. Okay, so obviously it is select, open, and from the property table. The design view is in is in front of you, and the SQL view is in front of you. The datasheet view actually runs the query and generates the result. This is the same as selecting open on a query through the query manager interface. Okay, so this is how you can able to